Is the engine the heart of the car? I believe the engine is more like the stomach of the car. The human stomach converts food into energy and stores it in the body. Similarly, a car engine converts fuel into mechanical energy. The larger the displacement, the higher the fuel consumption, and consequently, more mechanical energy can be converted. Let's explore how the engine converts fuel into mechanical energy. The car engine relies on fuel combustion within the cylinder. The heat generated drives the piston up and down, smoothly converting it into mechanical energy. The piston completes a four-stroke cycle with two up and down movements: intake, compression, power, and exhaust. The first stroke is intake. The intake valve opens, the exhaust valve closes, and as the piston moves downward, vacuum pressure draws air and fuel into the cylinder. The computer's ECU controls the air-to-fuel ratio, which is ideally 14.7 to 1 for complete fuel combustion. This ratio results in higher power conversion rates and minimal exhaust emissions, 14.7 kilograms of air to 1 kilogram of fuel. The second stroke is compression. Both valves are closed as the piston moves upward, compressing the air-fuel mixture for thorough mixing. Gasoline engines typically have a compression ratio between 9:1 and 12:1, while diesel engines range from 12:1 to 22:1. Higher compression ratios result in greater density of fuel and air, producing more thrust upon combustion and thus stronger power. The third stroke generates power as the piston reaches its top position, known as top dead center. A spark plug ignites in gasoline engines, similar to a lighter igniting a compressed fuel mixture. The ignition forces the piston downward, converting fuel into mechanical energy. Diesel engines compress and ignite without spark plugs due to diesel's properties. High temperature and pressure cause spontaneous ignition. The fourth stroke is exhaust. With the intake valve closed and exhaust valve open, upward-moving pistons expel burned gases from the cylinder. This completes one four-stroke cycle, with the next downward piston movement beginning intake again. During high-speed driving, this cycle occurs rapidly. At 3,000 revolutions per minute, an engine averages 25 four-stroke cycles per second, with each piston moving up and down 100 times, a frequency that would be quite intense for a massage.